Hey everybody, today's lesson is going to focus on poolroom math. I'm sure you've all played pool before, or billiards as it's called. Have you ever thought about the geometry that's involved in playing pool? How the balls bounce off of one another? The angles that are created? How to calculate the right shot? Let's take a look. Knowing your angles in pool is extremely important. You can see in the three diagrams on this slide, the angle in which the cue ball will bounce when it hits another ball is shown with the white line. Take a minute and look at these pictures carefully. In the top left corner, to make the ball into the corner pocket, you have to hit it at a specific angle. In the top right corner, the cue ball is being hit, and the red and the blue ball are both bouncing off at different angles. Same thing in the bottom right corner. The cue ball is hitting the blue ball, forcing the blue ball in one direction and the cue ball in another. Understanding the angles at which these balls will bounce is important in being able to play pool. Here's the math that explains how a billiard ball bounces off the rail. So imagine your cue ball is down here, and the path that your cue ball is hit is in this direction. The cue ball bounces off of the rail and strikes the 8-ball, forcing the 8-ball in that direction. Now the math behind this involves incoming and outgoing angles. And what we know is that the incoming angle, which is the angle created by the path of the cue ball and the rail it is hitting, will be equal to the outgoing angle, which is formed by the path of the cue ball off of the rail and the rail itself. So we now know that these two angles are congruent. Now, when examining incoming and outgoing angles, don't make the very common mistake of measuring this angle. I'll call it theta. That is neither the incoming angle or the outgoing angle. Computer scientist and professional pool player Nestle O'Hare must do quick calculations with angles in order to execute the proper shot.